Okay, so good evening. See a wonderful crowd here. Just give me, actually, give me a brief about myself. Basically, this is the first time I'm actually speaking in a forum. I mean, in terms of Sri Lanka, and also this is the first time I'm actually attending this group meeting as well. Invitation of Dinesh. I'm actually serving in the capacity of a solutions architect at CAMS. I been there like 1.5 years, and before that I was in Singapore about 3 years, and before that European BBC, now known as Dynamics. So today, actually, what we are trying to talk about is SQL Server CLR integration. What Dinesh told was is fairly new subject to the forum because this has not been spoken before in the forum. So just for me to know, are we all from a development background? I mean, in terms of software development background? You can raise hands, everybody. Right, perfect. So how I'm going to deliver this is basically we will be talking about a simple introduction to CLI. I know most of you might know what CLI is and the and then we do an introduction to SQL Server CLR integration, a very simple introduction. Then what is CLR? What does CLR stand for? So can anybody explain me what's the purpose of CLR and what it does? Anybody? What's the main purpose of CLR? Anyone can raise hand? Basically, CLR is a platform, right? Where you have a certain set of primary libraries, right? Yeah, it's cutting with it. Common language runtime. Runtime that is usable by different programming languages, right? Now, you know, CLR is basically a set of libraries, right, which is developed so that any programming language, right, could compile into that, and from there onwards, the platform takes place to execute a program, right? So we know about all the .NET languages. C#, .NET, this is the basic stuff that we need to basically do the programming, right? But there are many other languages who are actually targeting CLR, right, as we speak. So, core features of CLR, right? There are a few features in CLR, basically like just-in-time compilation. It manages the memory of your execution process, and it loads the assemblies handling the security and exception handling, type safety, threats in translation. All this is managed by the CLR. So actually, we don't have to worry when it comes to writing programs, because CLR is actually managed by that. So there are many, as I said, CLR integrated languages, right? So you can see, as C#, Visual Basic, F#. I am quite surprising because there are a lot of universities actually coming up with these different compilers actually targeting CLR, right? Even PHP for that matter. So it's becoming extremely quite a common thing of people actually trying to probe into CLR, where we have different programming languages. Now, what is CLR SQL integration? Now, this is the subject that we actually need to talk about. Now, we usually do our queries, our stored procedures, triggers, and all those things, right, in SQL Server, right? What if we have a chance to write this in managed code, right? mean, there could be million times, I know you guys must have wondered if we can actually write this complex stored procedure in C#, right? Instead of using TSQL syntax, right? So this is where actually CLR SQL Server integration comes into the picture, right? Now, let's go to CLR again and just see how actually CLR works, basically, right? Now we know there's something called CLR, and there are programming languages, and when you write the code, and when you compile them, and when you execute them, how the CLR is going to come into the picture. Can anybody explain how CLR is coming into the picture while the program is getting executed? I mean, a basic thing, like you write a piece of C# code, right? And you build this code, and it gets compiled, and you have an output. It could be a DLL, it could be an executable file, and it is getting executed. And when this is getting executed, how CLR is going to come into the picture? Anybody have any idea? Really great. Good. So it's a simple diagram. I can simply explain how basically it works. We have different code files, right? It could be C# code, it could be VB.NET, or maybe J#, right? Whatever the language, it may be like any other languages that I have showed before. So you actually write this code and you build it, or you compile it using the compiler. So each of these languages has its own compiler. Now, can we use C# compiler to compile a VB.NET code? No. Have different languages, they have different compilers. So all these compilers will be compiling the CLR, compiling the source code into something called intermediate language, known as IL or CIL for that matter, right? So once you have this common intermediate language runtime, is known as CLR, is going to take place with this context, and it is going to execute it into the machine language, and finally you have an executable. This is the simplest form of how CLR is going to work. So this diagram actually depicts that. So I think it's understandable how it actually works. So in terms of a library or executable, how we can actually represent this? Let's see like this. All these things when we compile the source codes, now you may be writing an exe, or you may be writing a DLL, and your DLL might be comprising a couple of C# code files. So when you compile, all these files has to come together, right? And you might be adding a resource file on top of that. Maybe you have some information that you need to store, or maybe an icon file. You put all this together and you compile this into one single executable, right? So how does it work? It's something like this. Now say we have a Visual C# project, and I have C# source files which you write the code, and you have references where you actually refer to other libraries, maybe assemblies or any components or anything, and you have resources, right? And mind that is 2.0 compiler, maybe it's could be higher version. You have C#2 compiler, and it actually compiles. I mean, the idea of the word compiler just means compile. So the whole purpose of the compiler and the whole job of the compiler is to compile everything. So it actually compiles everything into a managed assembly. It could be an exe, it could be a DLL, right? So MSIL, it actually contains the MSIL metadata. If I go down this part a little more, basically like when you actually compile into MSIL, Microsoft Intermediate Language, right? It actually contains something called header file. In the intermediate file, you have something called header information. The header information actually contains something called is portable executable, PE. So like if you're actually building this for 32-bit systems, it is PE32, and if you build this for 64-bit systems, it will be PE32 plus. So actually determines when you actually run an application, where should it run, what is the processor architecture it should run, is determined by that header file. So if you actually build a particular source code into a 64-bit target CPU, could that be running in 32-bit environment? Okay? No, cannot. Why it cannot is that the executor, basically the CLR, is going to look for the header file and it identifies what is the portable executable type. The portable executable type is PE32 plus. It knows that it is meant for 64-bit environment, so it actually cannot run that. This is where you commonly see this message saying that this library is meant for 64-bit environment, so you cannot run it in this computer, right? So finally, your managed code, it comes to the .NET framework, which is the CLR is going to take place, and you include you kind of the security, the garbage collection, just-in-time compiler, all these things, and finally you get the output telling your operating system and coexists and works at the next level. So this is basically how the modules are being compiled into assemblies, and assemblies are being distributed as program execution. Okay. So what is CLR SQL Server integration? This is the part that we actually are going to cover today. Now, I initially told you if there is a way for us to actually write our stored procedures or triggers in C#, it would be great, right? We can be covered miles ahead from all these SQL developers because we know C#. So that is one added advantage. Out of this crowd, have anybody done SQL Server CLR integration before? You can raise hands. Yeah, okay. What kind of a project was it like? Okay. Right. So you use CLR integration instead of using TSQL. Was there a problem of using TSQL in that scenario, or you just made the decision to use CLR integration? Okay.
It will be difficult to write to TSQL.
Right. Okay.
And also like the bandit management.
Right. Oh, that. Okay. Yeah. So these are the reasons actually we need to use CLR integration time to time. In my case, I have used CLR integration intensively on one of my previous projects back in Singapore. This actually, project is actually a government entity it's called Monetary Authority of Singapore. It's like the finance ministry. They had this automation when you need to open a company. You have about 87 pages PDF file where you need to fill. Whoever the client who's opening the company, he has to fill that. And then what they do is they upload this PDF file directly to the system, right? And system should then and there generate a reference number for him and just give it to him, right? But the amount of validations that has to take place is massive. So if we thought of, okay, like you can implement this in C#, basically when you upload the file, what we do is we extract the information. Basically, we were using something called Adobe Live Server. Then we extract the information and do all the business validations there. And finally, when it is okay, we just give the user the reference number and all that. This process became very, very tedious. So what we actually did was, we implemented the whole logic in one DLL, right? And we managed this as a CLR SQL Server hosted stored procedure. And everything became very, very easy, right? So users will seamlessly just upload the file, it goes to the SP and it's extract and processes and everything. It happens inside SQL Server, basically extracting the whole business logic. Everything happens inside SQL Server, business process, and SQL, the SP itself is just creating the record and giving the user. So the user doesn't have to wait, he just has to upload the file, he get the reference number. Everything else is taking place behind. So this, we actually use CLR integration very thoroughly, right? So we actually saw this is an added advantage that we actually could do this, right? So what is SQL Server CLR integration? It's the definition says that process of authoring, stored procedures, triggers, user-defined functions, user-defined data types, and user-defined aggregate functions in a managed environment, and then you host it in SQL Server. Right? So basically, this is what we actually do, right? So pretty neat stuff if you can do it, because I know one thing about CLR integration is it's not mainstream, right? When I say it's not mainstream, that not most of the people use it. I have no idea why, but it could be having its own reasons. So this is basically CLR integration. Now, if you are to do CLR integration, right? There's not much of a requirement there. You just need to enable CLR integration in your SQL Server, right? It's just a couple of SQLs. SQL Server must be first enabled with CLR integration. So if you just run this, your server will be ready for SQL Server integration. So it's a SP configure, and you make sure that you make it CLR enable 1, right? And then you reconfigure. Your server is now ready for CLR integration. You can turn it off by putting 0 here and turning it, right? So this is the only requirement. There's no fancy requirement as such with documents and documents. It's nothing like that. So it's simple, right? Now, let's say we have made your SQL Server environment is CLR enabled. Now what we need to do is simply write something and make CLR work, right? That brings us to the lab time. Okay, lab time, what we try to do is we try to do something interactively, right? We actually try to write something, create a database, and then see how it works, right? Okay, let's get a scenario. Let's say that we are a software company, and this bank is going to ask us for them to give the system to monitor their credit card transactions, right? Let's say if a user goes and spends more than $100,000, it has to be alerted to the system and saying that, okay, this guy actually spent this much of money, so this is kind of a warning, right? It has to be fired from somewhere. So let's say the bank has this database which all the transactions, the credit card transactions, we go and purchase, and all these transactions come into the database, right? And whenever the record is getting created, it has to monitor the record and it has to alert back to the bank saying that, okay, this guy is actually spending over the limit. Now suppose we can't actually do this. I mean, there's a condition that we can't implement this business logic with our code, with an application, right? Now, if we are to do this, what is the best way? I mean, can somebody tell me, if you don't have any idea about SQL Server integration, what would be the best way you achieve this scenario? How are you going to do it? Can anybody raise? Anybody can? Yeah. You know nothing about SQL Server integration. You have given this requirement. What will be your approach? Can anybody tell? I mean, it could be out of the box and just come up with a suggestion, like how you can implement that. Any idea?
Triggers.
Using
Triggers.
using triggers. So you're manually writing a trigger to using TSQL. Okay. So let's say I complicate the requirement a little. Okay. Now bank says you need to alert the user. How are you going to alert? Is by sending an email, by sending an SMS, and you need to execute our web services and pass all those data to those web services, and all those systems has to be integrated. Could we do that in TSQL? You need to send an SMS, you need to send an email, you need to execute a couple of web services. Right? So as the requirement is getting more complex and complex, right? It's going to be really hard for us to manage this one, right? So the only option is for us to basically, if we don't have this, we write probably a Windows service or any other service which is listening to our data stream and then execute the business logics and then fire it then and there, right? So the service has to be deployed, and this is the added overheads that is getting introduced. The service has to be deployed, and source code has to be maintained separately. It's a different application. There are many obstacles, right? What if we can do this using SQL Server integration, CLR integration, right? It'll be pretty simple because you just deploy it and you host it in SQL Server itself, right? True, we're going to write a trigger, right? But the usual TSQL trigger is not going to give us what we need. So we need to have more complexity and more functionality. So what we do is, we will simply use TSQL integration, SQL Server integration in CLR, and we are trying to build up a library. Okay? So let's get started with something. Refreshing. Okay. Now, in order to do this, let's quickly come up with a database. Okay. First of all, we'll just create a database and a simple table that will store our credit card transactions. Okay. So what I do is I'll just create a new database. I'll call it credit card monitor. I have my credit card monitor database. I'm just going to add a simple table here. This will hold my transactions. Right. I have an ID column. I say this is identity column. I say customer name. I say transaction number. This is my primary key. Save this. I say this is CC credit card transaction table. Now, if I go here. Have my CC tran, and maybe I insert the record. My transaction number maybe something like this, and my amount is 2000. So I have a record. Now let's suppose this table is the table all these credit card transactions are pulling into, right? Now our objective is to identify a transaction which is going to be over $100,000 and it has to be alerted to all the relevant parties, right? Now we decided that we are going to go through the path by using CLR integration, right? So I'm going to write a trigger which is a managed trigger, right? And I'm going to host it in SQL Server environment. So I do this by firing my Business Intelligence Studio. I'm just using 2008, you can always use Visual Studio 2012. I have another project open so I can't close it too later. So what I do is, I go to new project. I need to look for a project type here, database project. I select the database project and I select SQL Server project. And probably I name this project as CC Credit Card Monitor, CC1, right? Right. Now, when I create the project, it's actually asking me what database actually you're trying to point to, right? Now, I have to specify my database here by making a database connection. So I will connect to this. I'll select my database in here. And I select my database from here, which is CC Monitor. And I test my connection is okay. Right. Now it's asking to debug this project, you must enable CLR SQL debugging for the connection. Not that during debugging all managed threads will be stopped. Do you wish to enable SQL CLR debugging for this connection? You just say yes, right? So that you can actually debug using your test scripts later on when you are going to debugging, right? I'm not actually covering debugging here. I'm just giving a basic example of how to write the query and deploy, right? Now we have our project ready. Let's have a look at the properties of our project. Now, mind you, this is a very straightforward C# code that we are going to write, right? And as you can see, as the project details are going to be the same as you see in your usual C# application, right? You have the application menu, build, all these. Only difference is that you might see a database tab where you actually see your connection string to your database, right? And you have some permission levels and you have menu and all that, right? So it's quite straightforward. Now, what is our objective? Is to write a trigger is actually going to help us identify these transactions. So what I do is I'll right click on the project and I'll do add and probably your trigger. So I'm going to add this trigger and I probably call it CC on trigger. As you can see, it has the extension of CS, not SQL. So you're certain that you're going to write a managed trigger. That's not PSQL. You're basically going to write actual code. Okay. So this is our usual coding environment. And you can see what are the libraries that we have imported. As usual, it has system and system data and system data SQL client. And something we see is Microsoft SQL Server .server is being added as part of it, because we need this in order for you to actually host this in the SQL environment, right? Now we already have a pre-written code. Now the first thing we need to do is that, okay, since we are going to write this trigger, there is one attribute in this static constructor of this, right? I just enable this and this has to specify what is the trigger name and what target this trigger is going to be invoked with, which is the table name, and what is the event is actually going to fire. Now, what is our table name? Is CC trunk. So this is the table we are actually going to target. And what we are trying to do is, when there is a transaction going to get created, like when guy goes to a shop, swipes his credit card, and this transaction comes to the database. So we are talking about an insert, not an update, right? So I change this for insert. Right. Now, I can simply write my code here, right? Explaining the business logic. So first of all, what we need to do is we have to get the context of the trigger. Now basically, like when you actually come to a transaction, right, you're inside the transaction, you're trying to insert something, there is a context created. What we're trying to capture here is that particular context, right? So I have SQL trigger context. I call this context. Two types of triggers, SQL environment. I'm sorry? And before triggers, yeah. I mean, you can actually categorize in that way as well. But what I'm saying is like, mainly like you can talk about. Okay. Okay. Yeah, it's called DDL triggers and MDL triggers, right? Basically, this is the main. It's data manipulation. I'm sorry, DML, right? Data manipulation triggers and data definition triggers. So the data manipulation triggers are basically fired at the time you do an insert update, or basically your CRUD operations, and the DDL triggers are actually fired at the time you alter the database, alter the table, or create a table. Basically, this is the difference, right? So here, in this case, what we are trying to capture is the CRUD operations, and we are trying to capture a specific event of record creation. So I need to specifically say that I'm going to run my business logic at the time this record is going to get inserted, right? So what I do is, I say context, I have something called trigger action. My trigger action is insert, right? Now I'm writing, okay? So anything else I'm just ignoring. If the trigger action is going to be an insert, then my business logic is going to work here. Now, my next objective is, I need to get the data which is getting inserted from the source system, right? Because that is the data basically I'm trying to evaluate, to identify whether this transaction is over the limit or whatever it is, right? So let's say I need to put these values. Basically, we have a customer, we have a transaction number, then we have an amount, right? So I define three local variables here. TRN number. Then I have TRN amount. Right? Now these three local variables are going to hold my data, right, at the time of insert. So how am I going to read the data in this context, right? We use simple SQL client and read the query, right? So what we do is, I use SQL connection here. Now, this new SQL connection, it has a constructor where you can give connection string in. Now, in this case, this is something special. For these CLR integrated queries, we need to get the connection string in that context itself, right? This can be done by doing this. You can simply say context connection equals true. And we use that, it will actually going to create a connection within that context, right? Using this, we can execute whatever the commands over there, right? Now I have my connection. What I do is I open my connection. and now I define probably SQL command. New SQL command, and this command's connection is going to be con, and this commands, it's bad practice, I use a very similar name, so please bear with me. Then I use the command text. Okay. Now first what I'm going to do is I'm going to identify who's the customer, right? So I can simply write this SQL, select. I need to get my field name for the customer, so it's customer name, right? Customer name from inserted. So what does this statement mean? I mean, it's not a table, right? You do a select, but it's not a table. What we're trying to do here is I'm going to extract the customer's name from the inserted row. Simple as that, right? So basically, it gives me the customer's name. Then this is simple enough. I can just put this value to my customer variable. So I say customer, then I have this com, and I do a execute obviously scalar. This scalar will give me the customer's name into my customer variable, right? Now I have the customer's name. What else I need? I need the transaction number. So what I do is I will change my command text again. Instead of customer name, I will tell TRN number, right? So I can take TRN number, correct? TRN number, yes. Now I'm getting the TRN number from inserted, and I'm putting it to TRN number right here. And I need again the transaction amount. So here what I'm going to take is TRN amount, right? Now if I put to TRN amount, it's actually defined as a double, so what I need to do is convert this to a double. Right. So we have all the three values what we need now. Okay. Now it's time to evaluate our business logic, a very, very simple business logic for us to just see whether this customer is going over the limit of the transaction, right? So I simply say if TRN amount is greater than, is it 100? Yeah. If the TRN amount is more than 100,000, now what I have to do, right? First, the bank has given us business logic, right? Send an email, send a SMS, call the web services, right? And these are our business logic. Now this could be getting more and more complex as it goes, right? But for now, we stick to sending an email, right? So now we need to find a way to send an email. So I probably quickly write email class here to send the email. Now we are in a static method context here, so I have to write my private method in static as well. Otherwise, I will not be able to call it properly. So I have a private static void sendMail. This sendMail method is actually going to send an email for me. So I need to specify the customer name, transaction number. Then I have transaction amount here. Okay, so now before I came here, I basically in order to do this, I just created a free email account from Gmail. just called it, sorry, a different name, and account, it's called SSSLUG lab. The password is SSSLUG91. I just log into this, it's a fresh account, doesn't have emails. So this is the mail that we are going to actually, suppose this is the bank's email, right? So this is where we're actually going to get our email. So what I'm going to do is, I'm going to write an email sending snippet here quickly. What I need is actually to bring down a couple of libraries. By the way, what is the library that we use to send email? What's the namespace? System dot. There are two libraries actually send emails, right? The web could send emails. We use system.net, and we're saying again use system.net.mail. Then use both these combination of it because. So. Oh, okay.
No,
Sorry? Oh, yeah. Sorry.
it has 15.
Is that too big or it should be okay? Okay, back to my send mail. Do a mail message. Right? I need to create a mail message. I've got this MSG equals new mail message. It has a constructor for you to specify from two addresses. So what I do is I use our SSSLUG.lab@gmail.com. And this is the sender as well as the receiver, so I just use both for this. And then I need to define my SMTP client. New SMTP client. Now it has a constructor again for me to specify the host and in the port, right? So in this case, what I'm going to do is I'm going to use Google's Gmail's outgoing SMTP and send our email. So my host will be smtp dot should be Google or Gmail? Should be Gmail. Gmail.com. Remember the port is 587. Remember it has changed. It used to be 587. So okay, I have the client SMTP client set up now. So I need to set few properties here. I set the delivery method since we are actually routing to the network. Use the network. Then we have to say that this enable SSL to true, so that this is going through a secure channel. Then we specify what else? We have to specify the. We're not going to use the default credentials. So this one, use default credentials to false, and we are going to specify our credentials with the username and password. So CLR credentials, I have to give new network credentials right here. So basically I need to specify the username and the password, which is the username password that I'm trying to log into the Gmail. So sslug.lab@gmail.com, and my password is SSSLG911. Okay, now we have specified the credentials. So basically this is what we need to send an email. Then what I do is simply cl.send. Before that, we need to specify what is the subject and the content of the email. Sorry, message. Say the subject. I say credit card transaction alert. And my body, I would say, okay, alert. I say, I keep 2 lines due to any new line constraints. Then I specify the customer. I use the parameters which is coming from here, customer name. And I say made a transaction of, then I have to specify my transaction amount. String. The transaction of this thing with transaction number. I have to specify my transaction number. Right, that's my body. So I have the subject, I have the mail body using all these data. Then I'm trying to send this using my client. SG. Done? Okay, fine. So now I have the email sending logic here. I need to call this right here, right? I already have my transaction data, the client and all everybody's name here. So I need to call my send mail method here. With my customer, I already have a customer variable. I have my transaction number variable. Then I have my transaction amount variable, right? And the mail will go. Now we have the code written. Okay. Now what I'm going to do, I'm going to build it. Right. Will be successful. So CLR is going to take this code and convert all the things that we just talked about, and it is ready for deployment. Right. Now there are 2 ways of actually deploying a CLR managed library. Right. Either you can go to SQL Server and manually deploy it, and my preferred way is that you have your Visual Studio environment, you can directly go here and deploy it, right? Since our database connection is already made to the database, there is no problem, it will automatically go and deploy your assembly, right? Now, before deploying assemblies, do you know how we see what assemblies are already deployed in SQL Server? Any idea? How are we going to see what assemblies are already deployed?
Programmability
I'm sorry.
in the programmability tab,
Okay.
and there are CLR also.
You mean in the Visual Studio?
No, it's SQL Server.
All right. Okay. You mean here?
Assemblies.
All right. Here. Yep. Here you can see what are the deployed assemblies, right? It's another way, right? You can query for sys assemblies. If you really need to look into the files, sysassembly files, this gives you what files you have in the assembly, right? Now we are ready to deploy. What we try to do is we go build and we go deploy solution, right? It says in the taskbar deploy started and deploy succeeded, right? Now our library had been deployed. Just go and check whether it had actually deployed. So you can see CCMon, which is our library name or the assembly name, is deployed. And few things here like basically like your CLR name and you have the version and your culture and all that things. How this is going to change is that if you go and change your assembly info file and probably give a version for that, those information would be actually going to reflect here, right? So it's always a good thing to manage your libraries by versioning them so that you can query and find out which version is actually deployed, right? And you can see one interesting thing I'm going to talk about here is that permission set description is safe access, right? It is set to safe access because why it is set to safe access is that when we go to the project, at the time we actually build here, we had permission level set to safe, right? So that's why it is saying safe access. Now, this is deployed, right? And probably this going to show up here as well. Yes, now you can see assemblies, it has CC1 as well, right? Okay, now let's go back to our business logic. Now the trigger is already deployed, right? Now how long?
5-10 minutes.
Huh?
5-10 minutes.
Right. So what we're trying to do here, now we're going to execute a query and see whether our business project is working, right? Now, I will execute this statement again. I'm trying to insert this again, the different transaction number probably, and the amount is 2000, right? Should my trigger fire? No, because it's not fulfilling the business logic. The row is getting inserted, right? I can see the row is actually there, right? Now, I'm going to increase my 2000 to 200,000. Now, ideally, my logic should fire, right? Okay. Now, when I execute this happens. There is an error. What is the error? Is that it says something to do with permission, right? So, it actually doesn't allow you to fire a different assembly because the permission level is not set properly, right? If I quickly go back to my presentation with this slide, there are 3 types of security levels. Where is it? So, oh my God. Okay. First one is the safe. That's the default option, right? That accesses only the CLR code. No access is allowed to external resources, thread management, unsafe code, or interrupt, right? If you write a CLR assembly using a safe mode, right? It doesn't allow you to do all this fancy stuff. Not even, you can't even spawn a new thread, right? It is restricted. But the second one is that external access, right? External access is going to allow you to access the system resources such as event log, file system, network, still no access to unsafe code or interrupt, right? Still not going to allow you to use a SMTP library, right? There's one option called unsafe. Unsafe is there's no access restriction. You can actually use any interrupt code or unsafe code. So what I'm simply going to do now, I go back to my project, right, and go to properties, and I change my permission level to unsafe, right? Ideally, this should work. I set to unsafe, and I go, and I'm trying to deploy my solution. Then what happens? There's another error pops up. It says SQL Server doesn't allow you to deploy an unsafe library because it's set to unsafe now. So the database is not going to allow me to deploy this because it's set to unsafe, right? So what we're going to do is it says that if you make your database trustworthy, for those assemblies, yes, then it's okay, right? So you have to be an administrator, or else you have to go and ask your system administrator to make this database trustworthy, so that all the unsafe assemblies could be deployed. So I simply go here and I do something like this. I do an old database, and my database name is CC monitor set trustworthy on. Right. Now my database is trusted for these, right? There are two ways of doing this. Either you can do this, you can make your database set to trustworthy, which is very unlikely going to happen because your administrator would not do that. The other way is that you're going to sign your library, right? Whatever the CLR you're building, you have to sign it. Then there's no problem. Now just for the demonstration purpose, I have made it trustworthy, right? Now I should be able to deploy this. And deploy started, deploy succeeded, right? Now my library again deployed. Now if I go back to my assemblies, now you can see my permission description is unsafe access, right? So it's an unsafe one. Now what if I do execute this code, what is going to happen? So just I change my name to Dinesh. So Dinesh Priyankar is going to do a purchase of $200,000 worth of goods from somewhere. And I execute this. So the query is getting executed. You can see the delay, right? Because the code is actually getting executed behind my business logic, and it says the row is getting affected. So if I go to my CC-tran, Dinesh Priyankar had actually purchased 200,000 worth of these things. Now my alert should go. If I go here, I have an email saying credit card transaction, alert, the customer Dinesh Priyankar made a transaction of $200,000 with transaction number, whatever, right? So the bank is alerted now, and if we have all those SMS integration and web service integrations, they all would have fired by now, and everybody's alerted, right? So this is a simple way of integrating SQL Server. So I'm rushed with the time, so I move on quickly so that you can see the potential of this. So many things that you can do whenever you stumble upon something really complex. What you can do is implement this, and you can get by, right? But don't go tomorrow and tell your boss, hey, I have an idea, let's convert all our stored procedures to CLR. No, it's not going to work because there are pros and cons, right? So let's see, I'm not going to maximize this, right? What are the process, right? We have the power of .NET Framework, right? Basically, there are so many libraries available for you, and you can interop using interop. You can use other libraries, assemblies, and you can build up your whole business logic. You can handle complex calculations, and you can use regex for passing your strings if you need to specifically pass them. You can have usually defined types, and you have the facility of debugging the managed code using, and you have IntelliSense when you write the applications, right? And one fact is that is actually quite fast. There's one thing about CLR aggregation is 100 times faster than a cursor, right? So these are the facts basically, or we can identify. What are the cons? As I said earlier, it's not mainstream because it's not famous among the development community. So one thing is that TSQL, but the TSQL, right, is designed for optimized data, right? Designed and optimized for data, unlike CLR. So there are some advantages of TSQL you can't even match with SQL this thing, right? Example of pivot-based SQL manipulations and everything. I don't think you can have it in CLR because it is so complex, right? Yes, it's expensive to rewrite the TSQL logic. If you have a huge stored procedure, is going to, if that developer is already left the company, you have no idea what's going on, so it's really going to hard for you to actually rewrite the business logic. And limited to TSQL supported data types. There are these things, but you should know when to actually use it, right? When to actually use it, there are few questions. Ask yourself, Do I need to manipulate data before it displays, right? Then use .NET and SQL Server integration. Do I need to do set-based operations such as pivoting? Don't use CLR integration, use TSQL. Do I need to have extensive computation or business calculations? Use .NET CLR, is easy. Are my developers SQL gurus but not .NET newbies? Then stick to TSQL, right? Do I have lots of stored procedures that are becoming hard to manage? Yes, best option to go for .NET CLR, right? So this is basically about it. Just need to, final conclusion is use TSQL for all data-related operations. Use CLR for complex calculations and transformations, right? So basically, thank you for your time. So, okay. What are the two types of triggers? Right. What's the difference?
Data manipulation is actually calculation. Data manipulation happens in water, data or table.
Okay, cool. What do you want? Anything? Look. Give me 3 disadvantages of using SQL Server CLR integration. I'll make it 2. 2 disadvantages, or probably why you should not use CLR integration. 2. 2. I have 2. 2. 2. Why you should not use 1.
One reason is rewriting CLR in the course.
You mean rewriting the existing?
Doing a small statement, you have to write a lot of lines of code in C#.
Right. It's 1 or 2? Okay. I want there's a t-shirt and there is a pen drive. Is it pen drive? Pen drive. Pen? Okay, last question. What's the 3 types of when you deploy a CLR assembly, right? There are 3 safety options. Over here, yeah. 1,
Save, unsafe, external.
safe,
Unsafe, external.
external. What is safe? I'm looking for a complete answer, right?
Safe means don't allow to use encrypt code and
You mean unsafe or safe?
safe.
Safe means what?
Don't allow to access uninterrupt code.
Okay, okay. Okay, unsafe.
Unsafe is
It allows
is
everything.
allowed to
And
external. Through the network. Same network.
Network.
Allow.
Yeah.
How is the CLR integration? Is it really good? So we will try to do sessions like that which we have not covered much, okay, and which are really useful. Okay. Now this session is all about dimensional modeling. Okay, I'm not going to discuss how these things are going to be implemented in Microsoft Suite, right? But I'll tell you what is this dimensional modeling and what are the things we need to consider and why we have to use. Okay, that's the thing we are going to discuss. you just go to the agenda, like you can understand what would be the content of this presentation, right? Okay. I know that most of you guys have not involved with BI solutions, but nowadays almost all companies are trying to get something done in terms of BI. Okay. So when it's come to BI, this concept or the technique called dimensional modeling is really important. That because this is the most used concepts when it's come to BI. Doesn't matter whether it's SQL Server or Oracle. Like it is applicable for almost all platforms. It's just a concept. Okay, right. So before going for the first one, have you heard about this term before? I know that you have heard about a term called dimension. But have you heard about the concept technique called dimensional modeling? Yes or no? No. Okay, fine. Like I'm sure that even though the term is not familiar with some of you guys, when I explain it, you will easily understand it. Like you might have already used the same steps. Okay, right? It's just another name for the set of things we normally do for BI solutions. Okay, so I'll be quickly going through these slides, but whenever you have a doubt, whenever you need a clarification on what are the things in this presentation, okay, right? So just have a look on this definition. What is BI? If you Google it, then you will be finding these sort of definitions, like how developer sees it, how client or the customer sees it. Like, but it's all about getting information or basically convert data into information and present it for business users in a right manner. Okay, they should be able to simply use it without calling you, without your help. Right? That's all about BI. If I'm the developer, I need to make sure the databases, presentation layer, logics, everything is perfectly defined and it is given for business users. They can simply use it. So if I'm the business user, I should be able to simply connect with whatever solution you have given, right, and get the information as I want, not the way you want. Like most of the time, what happens is we create a report and publish it to the business user. So business user has to use the report, even though that's not the exact the report business user wants. Okay, so if it is a real BI solution, business user should be able to go to the solution and get the data as he wants and analyze as he wants. Okay, so that's how it goes. These are a couple of points related to history. I'm sure that you guys are familiar with the terms like EIS, DSS. Yes or no? Yes. Okay. Right. Okay. This is how it was started. Now read the third bullet point. The BI term actually it was mentioned in one of the articles called Hans Peter. Right. He has written an article where something related to data, but in that article he has used this term, but nobody noticed it properly. Okay, that's 1958. It was actually Gartner Group who really used this term for BI solutions. Actually, they started calling all the EIS solutions, DSS solution as business intelligence solution because they believe that that's the proper word to use for solutions like DSS, EIS. Okay, so that's how the term came. And these are some of the goals, right? Okay, things we discussed. These are things you have to really achieve if you are going to implement a BI solution. Okay, it's easy to understand. Let me just jump to the next one. Dimension modeling. Okay. Go for this and just read it and tell me whether you understand it. Like you don't need to remember this definition. It's all about understand what is this dimension modeling, what it talks about. What it talks about. In simple terms, it definitely talks about data. Okay, so what is dimension modeling? Don't just read the definition in the slide. What is it? It's all about organizing the data, right, based on users' requirements, making sure the organized format or the structure is very simple for business users. Okay, So let's talk about the database design. Whenever we have a design requirement, okay, we just go through the requirement documents if we have, or else we talk to people and somehow get the database design done. So we'll be creating tables, stored procedures, right? Mostly tables and columns. Okay. Once it is created, if you are a developer, yes, of course you can go through it and query as you want. Okay. If you design a database for OLTP system and open it for business users to, go ahead and access it and get some reports done using this database, can they do it? No, it's not possible, right? Okay. Even though you use proper names for naming your entities and attributes, the tables and columns, right? It will be difficult to business users. Okay. So this is all about you create a structure based on the requirements coming from business users, right? And that structure is a very simple structure. It doesn't mean that it's technically simple. Okay, but you're making it sort of a simple structure that any business user can go into this structure and do the analysis as they want. That is dimensional modeling. Clear? Okay, right. Little bit of history on it. Now, we started, using this concept somewhere around 1980s, but actually this has been used 1960s. Okay, that's the history of it. Okay, it's not sort of old one. It has been used for decades, right? But that after 1980, it actually came to the BI solutions, and everybody started talking about it. Everybody started using it. Okay, so that's how it came to this IT world, right? So the benefits of dimensional modeling. Read it. Is it clear? So it's all about simple structure. Okay, you are not going to have tables like T01, T02, and many relationships, right? Many bridge tables, okay, and tables with 1,000 columns. No, you are not going to have that sort of structure in your database or even in your presentation lakes. It's going to be very simple structure and reusability. It doesn't mean that you're going to reuse whatever the tables, whatever the columns that have been added, right? It's all about whenever you have a requirement, you're not going to add something to your solution. It should be exist. Okay? When you design your dimensional model, you'll be talking to all people and design it, and later you get another requirement, right? You should be able to use the existing one. Okay, if you have properly designed your dimensional model, yes, you will be reusing it without adding new things. Okay, right. Deliver data that is understandable to users. Now, when it's come to it is understandable, right? It is all about making this dimensional model or this structure with proper business names, proper business terms. Okay, for example, let's say you have you are involved with sort of business that has selling products. Okay, now when it comes to selling products, you have an item called product, right? And that item or the product has product code, product name, size, color, and all sort of attributes. Okay. Business user to business user, they might be using different terms. Example, product code. Some of the business users, they have no idea about the product codes. Okay, but some of the business users, if they are really involved with operational stuff, yes, they know, like they can't remember names of the products. They will say, okay, the product 001 is the one we actually ship to this country. Okay, that's how they talk, right? So this is all about addressing those sort of scenarios. We have to always make sure we have used correct terms. Like without using something called product code, you can simply say it's a product. Okay, so it's all about giving proper names. Then business user can come to your model. It can be a database, it can be a sort of application, and that application or that solution says these are the things available. Okay, since those are in the proper names, they can simply use it, right? And query performance. Now everybody has accepted that if you have designed your solution using dimensional concept, definitely it gives you better performance in terms of data reading. Okay, we are not talking about writing, we are talking about reading. Okay, so if you have properly designed your solution using this concept, which means you have designed a structure that gives better performance in terms of data retrieval. Okay, right. Respond to changes in users, reporting needs. Like, it's one thing is when we design these things. Now, if it is a normal application, OLTP application, we talk to business users, we actually refer existing reports, and we make sure whatever the things we have discussed, whatever things we have seen, for example, a sales report, we make sure that those items exist in the solution. We don't think beyond that. Okay, right? Now, next day, business user says something else. You should not get that sort of questions once the design is done. That's the whole purpose of this concept, right? If you have designed your model properly, you might be adding things, okay? But let's say, for example, let's say in sales operation, business user initially asks for sales amount. He says like, he needs to see sales amounts by time, for example, right? Now, next day, he comes and says that I need to see number of orders by time. Now, when we discuss sales amount, you need to make sure you capture everything related to sales. Okay, so that request is it's not a new request if you have designed your dimensional model properly. Okay, so those are the benefits we get if you have designed it properly. Basically, if you have designed your BI solution, or even you can say it's your reporting solution based on dimensional modeling, then you will get all these benefits or the advantages. Okay. There are two key things involved with this concept. One is called facts, other one is called dimensions. Right? So facts and dimensions, can you understand these two? Fact, it says represent business measurements. It's quantitative, which means we are talking about numeric values that can be used for analyze your business. Okay, if it is a software company, what are the facts you can see? The software development company, what are the facts you can see? Everybody works for software development companies, right? What are the facts you can see? Salary paid, right? It's a fact, right? Okay. Number of extra hours spent, number of projects delivered, those are the facts. Okay, whatever the things you can consider as business measurements. Right? Somebody should use it as a business measurement. To measure your business, you can call them as facts. Okay. Then we have another element called dimensions. Dimension is all about, now read this one, textual descriptors that provide context for the facts. You take the fact, salary paid, that's a fact, right? How we are going to describe this fact, how the context is built around this fact, okay? Like total salary paid for the month, that's a context, okay? Right? How many have been paid for overtime, that's a context. You actually get the fact and try to build the context using that the context, you identify dimensions. Clear or not clear? It's all about you first understand facts and then try to find the context for your facts. When you try to find context to your facts, you will be automatically finding dimensions. Okay, so these are the two key things you need to understand when it's come to dimensional modeling. These are the two major components that involve with dimensional modeling concepts. Okay, right. Now, when it's come to dimensional modeling, there are two types of dimensional modeling. One is called relational dimensional model or dimensional modeling. Other one is called multi-dimensional modeling. I have highlighted a word called star schema. Have you heard about this word? I'm sure in a couple of guys. Have you heard about it? Star schema? Right, okay. Now see, this is with relational database management system. If you take SQL Server, right, database engine is the database management system. Right? Okay. And if you have implemented your dimensional model using relational database management system with SQL Server, with Oracle or MySQL, if you have properly implemented based on the theories, we call it as star schema. I'll tell you why we call it as star schema, but that's the name we have given for it. Okay. So implementation, like if you are going to implement something with relational database management system, you will be definitely creating what? Tables, right? Database and tables. Okay. So your, the structure of your table, or the relationships between table, or the columns in the table, once everything is combined, we call it as star schema. Okay. Now we have, once this is implemented with relational database management system, we have two types of tables. One is called fact, other one is called dimension. Okay, you can see fact tables are linked with dimension tables using foreign keys. Okay, I have another slide that explains this, so I'll explain it later. Fact tables hold measurement events. Now remember, when we discuss something called fact, we discuss, or we understood that fact is a business measurement. Sales amount, salary paid, number of orders placed, everything is business measurement, right? Now this says fact tables hold business measurement events. What does it mean? It's all about the event related to your business measurement. If your measurement is salary paid, what's the event? Company is paying your salary, right? That's the event. You record it. That is what we record in the fact table. Like number of sales orders. That's a fact. What's the event? Customer places an order. That is what you have recorded in this fact table. Clear? So this table holds events. Dimension tables. It holds descriptive attributes of measurement events. Remember the context? Now you recorded the event, and now you are going to describe the context. This, it basically says descriptive attributes. Now attributes, when you convert attributes to database structure, what are those? How do you convert attributes to what? Attribute becomes columns, right? So you will be having columns in dimension tables that describe the context of your fact, not the fact, actually the event. Okay, so dimension table contains something like, okay, let's take the same example. Company pays your salary, right? So that's the event. So it is recorded in the fact table, and dimension table, employee is a dimension, company is the dimension. Okay, whatever the things related to your event will be recorded in dimension tables. Clear? Let's go to the next one. This is multi-dimensional model. Now the first one we discussed is the relational dimensional model. This is multi-dimensional model. Okay. So this is implemented with multi-dimensional database management systems. If it is Microsoft SQL Server Product Suite, what's the component? What's the the software we have in terms of multi-dimensional? What's the analysis services? Okay, that is the multi-dimensional database component that comes with SQL Server, right? So what's the output of it? Earlier we had star schema. With this one, what's the output? Cubes. All are cubes. Okay. This says use multi-dimensional specialized storage and indexing. If you talk about the storage related to relational databases, okay. Now when you create a database, what are the files created in the file system? There will be two files. One is called MDF. Other one is called LDF. You cannot create a database without these two files. Okay, and again you can add more and more MDF, more and more LDF. Right? Okay. So it uses a general storage mechanism for holding those files, or integrating those files for holding your data, right? But when it comes to OLAP cubes, it has a specialized mechanism for holding data. From vendor to vendor, it is a bit different, but when it comes to OLAP, most of the components are same. The structure is same, but again, vendor, they have their proprietary features, functions, and all, right? But the concept is same. Structure is, most of the time it is same, right? So it uses a specific storage mechanism for holding your data, and it is not the index, when it comes to relational database management system, we know that there are set of different type of indexing, clustered indexing, non-clustered indexing, and we have something called column store indexing. Those things are available with relational database management system. But here we don't have clustered indexes, we don't have non-clustered indexes, but it knows how to index all of these things using XML. Okay? Because of that, it actually gives a better performance than relational database management systems. If you have properly designed your dimensional model, and if it has been converted to OLAP cubes, you will be definitely getting best performance. Okay, you can see you will get best performance with pre-aggregated and pre-calculated data. For example, if you have recorded sales amount, getting the total of sales amount for, based on whatever the condition you have given, say total sales amount for 2004 for this category, for this region, right? Think about if you are trying to get that answer from your relational database management system, handling 3-4 million records, unless you have a good infrastructure or the good box, it might take minutes, right? But once it is implemented with proper dimensional model using OLAP, most of the time within 2-3 seconds you'll be getting the answer. Okay, so that's the advantage. So remember, there are two types of dimensional model. One is relational, other one is OLAP. Once it is implemented with relational, it is called as star schema. Once it is implemented with multidimensional database structure, it is called as OLAP cubes. Okay, right. We discussed few things about fact table relational model. Right. So we discussed row, a record represent a measurement event. Clear? Right. It says no event does not require to be recorded. Now, let's say salary is not paid for March. It can happen, right? Okay. So if it is not paid, do we have to record it as a zero value? Sometimes when it comes to operational systems, we record it, right? We record those transactions in a different way. But when it comes to dimensional modeling, you don't need to record no events, right? Row at specific level is always analyze sales amount by week or month. But if you're getting it daily, hourly, right? Make sure you hold it as you get. If you're getting it by hour, make sure you hold it by hour. That is how you define the lowest level, we call it as grain level. Okay. Consume 90% of the space of the model. We normally expect millions of records in this fact table. Okay, we have designed data warehouses or data fact tables that contains millions of records. We are not you should not go for this concept if you are not going to hold at least 1 million records in your fact table. If you are talking about 100,000, 200,000, you can still manage with your relational database structures and relational concepts. But if you are talking about millions of records, then go for this model and create fact and dimension based on requirements. Okay. So remember, when it comes to fact table, we are talking about relational model. We have two types of table. One is fact, while other one is dimension. So the fact consumes 90% of your space. Okay. Deep in terms of number of rows, narrow in terms of number of columns. We rarely add 100 of columns to the fact table. but in terms of rows, we expect millions of records. Okay, so that's a fact table. Dimension table, row represents textual context associated with the measurement event. We discussed this. See the second bullet point? It describes the event. Remember, we were talking about measure and the measurement event, that is what we record in the fact table. And dimension table describes this event. Like who, what, where, when, how, why. Okay, that's what dimension holds. For example, when it happens, who did it, right? Where it has been happened. Those are the questions you get from business users, right? In order to answer, those questions, you need to make sure your dimensions are set with these events. So basically, dimension tables describes the event. Clear, right? So in terms of number of columns, very narrow, and you don't get much rows, you don't get much columns too. Okay, that is one of the characteristics of dimension table. Highly denormalized. What does it mean by denormalized? You are going to see what? Duplicates, right? Redundant data. Okay. So that is how we configure dimension table. Remember, fact tables normalize, but dimension table denormalize. For example, let's say if you have gone through AdventureWorks database, you have product, category, and brand, like different levels. Okay. So in order to maintain the referential integrity, we normalize our database. If it is all OLTP system, we normalize it. We have one table for product, one table for category, one table for brand. Linking, using what you call the foreign keys. Okay. But when we design a dimension called product, we will be having one table that contains everything, which means it is a denormalized table. But there are instances we normalize it too. Okay. So if we normalize it, it is called as snowflake. Sometimes we refer the star schema as snowflake schema if dimension tables are normalized. Okay. This is how we combine fact and dimensions. So the middle table is the fact, right? We record all numeric values and then link dimension tables using foreign keys. This is the relational dimensional model. Okay. You can see actually it forms a star. That's why we call this as a star schema. Okay, clear? Now see this date dimension is there, customer dimension is there, product dimension is there, promotion, and something called currency. Clear? Okay. So once this is analyzed, you'll be ending up with a table structure like this. That is your relational dimensional model. Now once this is converted to all up mode, right, you will be having facts and dimensions again, but most of the time, what happened for the fact is basically it is converted to cubes. Okay, and you will be defining measures, calculated measures, something called KPIs, like everything inside the cube, taking values coming from these fact tables, right? And when it comes to dimensions, now for example, if you take the product dimension, or let's say date dimension, if I go back to this is your table, date dimension table. You have year, quarter, month, date, everything is there. Now once it is converted to all-up dimension, you get all these attributes. In addition to these attributes, it allows you to create hierarchies. You can create hierarchies. Okay, you can create a hierarchy starting from year, quarter, month. You can create another hierarchy starting from year to month, date. Okay, we allow business users to analyze the fact or the measurement using those hierarchies. Now if you go back to relational model, you can simply analyze sales amount by date, sales amount by month. But once it is converted to cube, we allow them to analyze the sales amount starting from year, get it expanded to quarter, right, and pick one of the quarters and get it expanded to months. Likewise, we can have any number of hierarchies with dimensions. Okay, so those are the advantages. Okay, I'll quickly go through these two slides. Now, once we completed our dimensional model using relational theories and then OLAP theories, there are two types of architectures that have been provided to this world by two person. One is called Inman, other one is called Kimball. You can actually search for these two architectures and read more. All I wanted to say is where this dimensional modeling concept is used. When it comes to Inman concept, this is where it has been used. When it comes to Kimball's concept, it has been used in third stage. Okay, let me explain this one bit because this is what we mostly use, right? We extract data from the systems using ETL, right? Then we define dimensional model first using relational database management system. Then we define the dimensional model using OLAP or the multi-dimensional database management systems. Okay, then finally we address the presentation. Okay, let me go for this. Right, dimensional design process. There are 4 steps you have to use if you are going to design your dimensional model. Right, first select the business process. Right, now I have seen many mistakes on this when it comes to selecting. One thing is you should not start. Let's say you're going to create a BI solution. You should not try to focus on the entire organization. You have to focus, but you have to start with one business process. But it doesn't mean that one source or one department. That is where people make mistake. Okay, it's not for the sales department. It's not for billing system. It is for business process. If the business process is sales, sales might be handled by 3 departments. There will be 3-4 sources involved in this business process. So you have to address all of these things. So remember, if you are going for BI solution, if you are going to use dimensional modeling concept, pick a business process, not a department, not a system. Okay, that's the key, right? That's what it basically explains. This is something called enterprise bus architecture. When you have discussion with your business users, you'll be listing out all your business process. Those are the columns, and these are the dimensions. So basically, when you talk to these business users, you can update this spreadsheet or whatever the document you use, right? If I take the first one, sales business process, it involves with date, customer, employee, product, geography. Likewise, you can mark. Okay, then you pick one of the business process and start declaring the grain. What is the lowest level they want to see? Okay. If I go back to this, it means that if I focus on sales, date is the lowest level in terms of date dimension. Customer is the lowest level in terms of customer. What are the other possible attributes for customer? His address, his salary, or there are various sort of other attributes. Like, all you have to understand is what is the attribute going to be linked with your measurement event. That is what you have to understand. Based on it, we'll be designing the grain. There are 3 types of grains or fact grains: transaction, periodic snapshot, and accumulating snapshot. Most of the time we focus on transactional one. It holds all transactions. Okay, but you can go for snapshot and you can accumulate snapshots based on some set of conditions too. Right. Third step, identify dimension. Again, we discussed some of the things. Now, in the third bullet point, define descriptive labels for all attributes, not operational codes. You need to make sure you properly name your attributes based on the business, and then define relationship between attributes and hierarchies. There are different types of dimensions. Once the dimension is identified using your business process, right? For example, customer is an identified dimension. Okay, then you have to think like what would be the type of this dimension. Let me give you an example, right? If you take attributes like town of customer, right? It basically says this customer lives in this place, right? Later, it is going to be changed. How we are going to manage that change? Let's say initially he was in Mount Lavinia, now he is in somewhere in Kandy, right? In operational system, we just change it, right? We go to the customer table and change the address, right? So what happens if you refer all transactions? Okay, not all of them. Let's say you are referring new transactions using, let's say, a town called Mount Lavinia. If you refer all transactions, then the correct values will be displayed. But let's say it has been changed now for Kandy, then you won't get any values for Kandy, any values for Mount Lavinia because it has been replaced. That's how we manage normal applications. But when it comes to dimension, you can actually maintain the history. We call it as slowly changing dimension. There are different types of slowly changing dimensions starting from 1 to 7. Okay, right? So likewise, you need to decide what is the dimension. Okay, based on it, you will be changing the structure of it. And the final step is identify the facts. We started from the business process, then we define the grain level of business process or the numeric values we identified. Then we decide dimensions. Finally, we are going to decide facts. Facts mean the real numeric values, okay, or the measures. Right? Let me just focus on the last bullet point. It says the category of facts have to be decided. Like we will be having additive facts, semi-additive and non-additive. For example, if you take sales amount, if you try to get sales amount for the year, everything has to be total up. Okay, that's additive. But if you think about inventory, stock, let's say you are recording stock per day. So you have your stock amount for product 1 for the first date, second date, third date, right? Likewise, you have stock for all the dates for the month of March, for example. So if you try to get the value for month of March, are you going to total up everything? Yes or no? If I total up everything, is it correct? So what should I take? The last one, right? That's what we have to take. Those things are called as semi-additive. Likewise, there are numeric values you should not add, you just take the value as it is. Okay, that's called non-additive. So you need to decide all of these things, and based on all of these things, you will be preparing another document called bus matrix that explains the link between identified facts and dimensions. This is what you use for designing your relational dimensional model, right? Once this is completed, you will be designing fact tables, dimension tables. Okay, I'm not going to discuss like how to design those things, but this is the general way. So these are the components we'll be using for handling all of these things using Microsoft technologies. We have to use database engine for finally design the relational dimensional model, right? We'll be using integration services for handling data transfers between sources and your dimensional model, and finally we'll be using analysis service for converting your relational dimensional model into Euler cubes. Okay, right. Some of the myths related to modeling, I'll just everything can be read and understood, right? Okay, I'll just take a couple of things. Like the first one is, this is what everybody thinks. Everybody thinks that BI solution is for summarized data. Everybody thinks that dimensional model is for summarized data. So it is completely wrong. It holds all transactions, almost all. Okay, that's the way. Like you don't know what would be the next question coming from business user. Business user might ask the total for the month today, but later he might ask give me the total for this date between 8 and 9. Okay, there could be, questions like that, requirements like that. So you need to make sure you are not going to hold only summarized data for the, basically everybody thinks that dimensional concept is for all about holding summarized data, but it is not. Okay, let me take another one. Okay, dimensional models are not scalable. It is scalable. You can simply maintain millions of records without any issue. Okay, you can scale out, you can scale in, no issue at all. Right. These are the references. I actually use the site called timbergroup.com. Okay, you can go to this site and learn a lot of things about dimensional modeling. And if possible, get this book and read. This is a really good book for understanding BI solution, understanding the design concepts, and this third edition, second edition actually it explains how to design all of these things using Microsoft technologies. How to design your relational data warehouse using relational dimensional modeling, and then how to create ETLs using integration services. What are the things you have to consider? How you connect with the source? How do you transform? How do you load the fact table? Everything is discussed in all these series. So try to get these. I don't know whether it's available for buying in Sri Lanka, and of course you can do a search and get ebooks. Okay, right. I quickly went through these slides without explaining much. Any question related to things we discussed? Everything is clear or not clear? No question? Right. I have 3 items. I'll quickly ask 3 questions. Just raise your hand. Okay. There are 2 ways of defining your designing your dimensional modeling or the dimensional model. There are 2 ways. Okay, so you can simply have one model and another model, right? What are those 2? Everybody knows, right? Star schema, okay. Ola. What do you want, Let me ask the second question. Now, if I have to design or if I have to do this dimensional model using OLAP technologies, what is the Microsoft component I have to use? Yes, asking really easy questions. Okay, last question. I explained about different dimension types. Okay, can someone tell me 2 different dimension types? I'm talking about, okay, let's talk about dimension. You can implement as a relational dimension and part of the cube. But there are different types of dimension. Okay, let me give one. There's one called slowly changing dimension. What's the other one? Parent-child. Yes, that's another one. Okay, right. That's all. It's already 8:30. I have 2 announcements, but before that, I have a bag that contains a couple of items: mouse, pen drive, e-voucher, and Microsoft bag. Right. Okay. This is based on the question we asked. I don't have a box today. Can someone take one of these things? And take one and give me this. This is going to be the number 70. Who has number 70? Yes. It is for you. I'll explain the question. Explain a couple of things from Microsoft, Redgate, and Oracle. Right. Now, this question is based on exist keyword. Right. Now, if I just execute select 10 divide by 0, what will be the answer? What would be the answer? If I say select 10 divide by 0. Yeah, you get an error that because you cannot divide things by 0, right? Okay. But if I write something like if exit within bracket the statement, what would be the result of it? Will it throw an error? This is what you have to remember. If you remember, we always say not to use select all from table. The reason it reads the whole thing. But if you combine exist and select all, it is not reading the whole thing. It just validates it. So same thing happened for this. If you say if x is select 10 divide by 0, it is actually not doing it. It just validates your statement. And it just checks and sees whether it will produce an output or not. That's all. It is not executing it properly or in a general way. Okay. So answer is if condition will be satisfied, it goes to the true part. It will print yes. Clear? Okay. There are two announcements. One is like we are trying to get new speakers. So if you guys can speak, at least spend 30 minutes and share your experience. Just let us know. We'll arrange it. Okay. Either .NET or SQL Server. Right? Just try to come and share your knowledge, share your experience. I'm sure that you guys have done so many things which we have not done. So we also like to learn new things. So try to come here and simply give a speech or do a session. Okay. Second announcement. By 1st of April, SQL Server 2014 will be available for downloading. Okay, you can download the latest and start using it. There are so many new things that have been added. We are trying to plan a set of sessions based on 2014 new features, right? But remember, by 1st of April, you can start using SQL Server 2014. Okay? Right. Okay. Thanks, guys.